All right, here's part 2 of our lesson. And we are looking again at a quartic. And so this is going to have, once again, 4 roots. What makes this a hair different from the previous problem is that we have a leading coefficient that is negative. So here's my advice to you. What we're going to do is we're going to factor out that negative first. And once we factor out that negative, then we could we will tackle this problem the same exact way we did the previous problem. So factoring out that negative reverses the sign of everything in there. With this negative now, we just got to remember at the end when we write this in factored form, we got to remember that that negative needs to be placed back in. All right, so let's make our list of possible rational roots. So our possible roots, not bad, this list, because it's just the factors of 2 over the factors of 3, which would be 1 and 2 over 1 and 3. So our list would be fairly short, plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 1/2. So only 8 values that we would have to try plugging into our function. Okay? And so once again, what I would do is I would use my calculator to my advantage, and I would take these 8 roots and plug them in to our polynomial. I would do it using my table, and so that would mean I would plug p of x into y1, right? So type that all into y1 and then use your table. And what happens is you end up finding 2 roots out of the 4. What do you find? You find negative 2/3 and you find positive 1. 2 down, 2 to go. These are our roots. And we don't know what those other 2 roots are. So what we're going to do is we are going to do synthetic division using negative 2/3 and 1. And then we'll be left with a quadratic, and that quadratic will hold those other 2 roots. So doesn't matter what order you do the synthetic division in. So what I'm going to do is I am going to use the negative 2/3 first. And once again, what I'm going to do is I'm actually going to divide after. I'm going to divide by 3 after I'm done. That will just avoid the fractions. Not everybody does it that way, but that's the way that I do it. You could do it by dividing first if you want to. I do know my remainder is 0 because I do know that negative 2/3 is a root. And so here we go. We drop the 3, multiply, add, multiply, add, multiply, add, multiply, add. You could see that this is all divisible by 3, so I'm going to divide everything by 3, which would be 1, negative 3, 3, and negative 1. And now I will do synthetic division one more time with 1, my other root that I found. And this turns out really nice. And so the remaining quadratic is x squared minus 2x plus 1. My other 2 roots are in here. And that is factorable. Oftentimes when we do these problems, what you're left with is not factorable, and you'd have to use the quadratic equation. But this is actually factorable. This actually factors to be x minus 1 times x minus 1. Or if you wanted to write it as x minus 1 squared, you could write it as x minus 1 squared. But that means that the other two roots are 1 and 1. All right, now something special has happened. You could see here up at our roots, since x being equal to 1 is a root that occurs 3 times, we call x equals 1 a triple root. If it happens twice, we would call it a double root. So there it is. Those are our 4 roots. Negative 2/3, and then 1, which we would count as a triple root. What is this now in factored form? All right. Well, negative 2/3, the negative 2/3 root would be 3x plus 2. So pop that in first. Oh, you know what? Got to put the negative in first. All right. 3x plus 2. And then x minus 1 cubed. If you wanted to write out the x minus 1 3 times, you could, but the easiest way to do it is just like this. All right, so that's part C. Here's my roots, that's part B. My possible roots, that's part A. And now I just have to graph this. And so I'm going to put a point at 1, x equals 1, and negative 2/3, right? This is a negative quartic, so it's going to be down and down. And so, oh, and our y-intercept is 2. Let's put that in there. So this is what I'm going to do. Now, for a triple root, what happens is you get this little wiggle. It just kind of wiggles right through. Rather than slicing through like a normal root would, it wiggles through. And so this indicates a triple root when you wiggle right through the x-axis. And there you go. All right, your exit slip is number 4. That's your exit slip. Good luck, and thanks for watching.